Hey guys, welcome back. So in a previous video, I did a tutorial for this 5-in-1 desktop hobby machine that I made. That it could be used for most hobbies, but in my case, I demonstrated the uses I found related to lapidary, metalwork, and jewelry making. A lot of people expressed interest in making their own and asked if I could provide the files. But since the original machine was made with a laser cutter, and most people don't have access to a laser cutter, I thought it might be better if I made a newer version, a 3D printed version, since 3D printers are far more common with makers these days, and most people either have a 3D printer today or know someone who has one. So I felt a 3D printed version would be far more useful. I'm currently out of work at the moment and I have a bunch of spare time, so I figured rather than just remake the previous machine exactly the way it was, only with a 3D printed case, I started thinking of ways that I could perhaps exploit the unique benefits of 3D printing and try to come up with something that's better. And I think I accomplished that. So here's the new version of the machine. Unlike the previous version, this design is entirely 3D printed. Aside from bringing the cost down even more, this design really expands the machine's uses almost infinitely, to be honest. All right, so this machine uses the same 500-watt motor with the same ER11 collet, so you can still put almost any size tool in here, and it can do everything the previous machine could do. It works as a flat lap or a slant cabber, a lathe, a polishing machine. You can run a flex shaft off of it. It could work as a tumbler or a parts finisher. You could still use it as a metal, wood, or lapidary saw. But this new design has a few additions that really make this version much better. All right, so let me go over some of the additions. By the way, I'll put a link in the description to the original version of this machine for those that didn't see that video. In that video, I spend a little more time demonstrating the jewelry making and metalworking uses, but in this video, I want to talk a little more about some of the additional uses now that are possible with this new version of the machine. So as you can see on this newer version, I got rid of the aluminum motor mounts that were on the previous machine. Eliminating those takes another like $15 or $20 off the finished price, but that's not the real benefit to switching to a 3D printed bracket. I had a much better reason for doing that I'll explain in a minute. But first, let me go over some of the additions on this newer version that make it much better. Here, I added a forward and a reverse switch that wasn't on the original machine. This can come in handy for a lot of reasons. For one example would be tapping holes. There's actually a lot of reasons for a forward and reverse switch. One thing about the previous version that I didn't like was the use of the flex shaft. I mean, having the ability to use a flex shaft was definitely useful, but it came at the expense of occupying the spindle. I kind of wished that I could have something in the spindle and also have a flex shaft running. So like you could have something spinning in the lathe and you can cut, drill, or polish it with the flex shaft, but in the previous version, you couldn't do that because the flex shaft plugged into the spindle. So what I came up with was this. On the back of the machine, I added this dim plug here. This allows me to, instead of using a flex shaft, it allows me to plug in a micromotor handpiece directly into the power supply. And now by doing that, I have two motors that I'm able to run at the same time. And you can get these micromotor handpieces for like $25 from AliExpress. And if you never used a micromotor, they are 1,000 times better than a flex shaft anyway, trust me. So now I can have something running in the lathe, and while it's running, I could use the micromotor to polish it, or I can put a cutting tool in the micromotor and use it to cut on the lathe, or I could put a drill bit in the micromotor and drill something that might be in the lathe. It's just so much more useful now. And it can also cut and shape metal. I mean, obviously the right way to work metal would be with a tool holder, and I plan on 3D printing one soon. But even with just this micromotor, it's capable of cutting and shaping metal already. What if you want to stop and position your work in the lathe, but keep the micromotor running? Like drilling something, for example. Here on the side, underneath the speed controller, I put a kill switch. It's a waterproof kill switch. By pressing that button, you can turn the spindle on and off. That'll keep power to the micromotor while killing power to the spindle, so you can keep the spindle stationary while drilling. And this type of micromotor is waterproof, so you can run it underwater, no problem. Another benefit of 3D printing would be having the ability to print a new rear fan. Because this rear fan is connected to the spindle, the new fan is going to have an indexer on it like this. So with a pin here to lock it. So I'll be able to lock the spindle in place and then index it like every 90 degrees or 45 degrees or whatever I want in order to drill, holes perfectly spaced. Or it would be perfect for stone setting. This is why this machine combined with 3D printing is so great. It really turns it into an everything machine. I recently saw a YouTube video of someone making wooden inlay rings. I have a bunch of opal chips laying around that I was looking for something to do with. So I just 3D printed this ring mandrel, and now I can cut a groove with the micromotor and learn to make inlay rings myself. Another addition to this newer version of the machine are these threaded inserts. I added them all over the machine. I have them on the sides, on the top, and in the front. There's even marking spots here for additional inserts if I want to add them in the future. These are going to be connection points for additional jigs, fixtures, or adapters that I'm going to 3D print for the machine. So I can put a whetstone in the collet, and by printing various attachments, I can turn it into a completely different machine. For example, there's this expensive machine I've always wanted called the Tormek T8. It's a professional sharpening machine that comes with a bunch of different jigs for sharpening anything from knives to drill bits, scissors, or gravers. But it's really expensive. It's like $1,000. By mounting a whetstone in here and 3D printing all of the tool guides that'll attach to these threaded inserts, I'll be able to do here what most of the Tormek could do. So these channels here on the side are going to lock into a 3D printed stand, and by turning the machine upright, you'll be able to convert it into a drill press. So I have a friend who's an animator, and he's building a stop-motion puppet based on one of those vintage monkey toys that bang cymbals. He asked if I could make him a pair of metal cymbals for the project, so I thought this would be a good time to see if this machine could do metal forming. It's something I've always wanted to learn. So I 3D printed this simple tool holder, attached it to the threaded inserts on the side of the machine, and I also 3D printed this conical shaped die from ABS and assembled this jig for holding the sheet metal. And as you can see, the machine worked perfectly. I still need to perfect my technique, but it definitely works. And he also needed some custom-sized springs for this project, and with the same tool holder, the lathe converts into a spring-making machine as well. Here, I found if I added sandpaper to the rear fan, it could double as a mini drum sander. I 3D printed rubber feet for the back of the machine, and with the help of this 3D printed stand that screws into the threaded inserts on top, I can now stand the machine upright, and after inserting a diamond plate into the collet, it now functions as a lapidary machine. Next, I 3D printed these discs, inspired by the ones used in split laps, that when backed with sandpaper and running at a high speed, they become transparent and allow you to see through to your workpiece. I love these. There's also threaded holes all around the front of the motor that will allow me to easily attach a 3D printed splash guard or attach a 3D printed table that can be used as a wood or metal router, a glass edge grinder, loads of possibilities there. Turn the stand 90 degrees, turn the machine on its side, and it becomes a bench polisher or a bench grinder. These indentations here are where the water tank is going to attach. So you can run odd-shaped diamond tools like these to make shapes like this that can't be done on a flat lap. Then I'm going to 3D print a cover for the water tank that'll convert it into a wet saw. It'll also be able to function as a wood or metal saw. It'll be able to do all the obvious leatherworking functions like edge burnishing. With the drum sander on the fan, you'll be able to sand edges without changing tools. I'm even going to make a 3D printed skiver, but the most exciting leatherworking feature is embossing. This style of micromotor has an interchangeable head that switches from rotary to reciprocating, and with the reciprocating head, the machine can convert into a hand embosser that allows you to literally draw embossing onto leather. I use this technique all the time. I love it. So there's loads of other rotary uses, like it can be converted to a pottery wheel for sculpting, and the variable speed allows you to slow it down enough so it can be used as a painting aid or as a rotary curing rack for UV resin. But it starts to get really exciting when you realize that combining the use of these mounting holes with the ability to 3D print more complex mechanisms like a Scotch yoke, that now you can convert rotary action to reciprocating. This opens up the door to a whole bunch of other uses, like a powered hacksaw or a die filer. And there's already lots of available work holding options like vices and chucks of all types and sizes, flexures, ball joints, and even linear rails, which can all be easily modified to fit the machine and allow it to perform some pretty complicated functions. Like, for example, let's say I wanted a device that could hold the micromotor and position it at any angle for precise drilling or milling operations. Traditionally, it would have required some sort of expensive mechanical compound slides. But when working on a smaller hobby scale, with 3D printing, it would be possible to print a tool holder based on something called a compliant mechanism. Take this one, for example. Notice how you can move the handle in any direction, but the tip of the pointer remains in perfect position. This is done cheaply and easily with 3D printing and requires no moving parts. That's just a few examples of the jigs, attachments, and uses possible with this machine, and I plan on 3D printing all of them, and a lot more. My goal for this project is for this machine to basically serve as a universal power supply. What I mean by that is instead of buying a dedicated machine for every use, this would be a single power supply that can be converted into any machine for almost no additional cost. This would apply to so many hobbies, but as an example, let's use my hobby, jewelry making. A beginner who's just getting started would typically buy a flex shaft or a micromotor as their first tool. And if they stick with it, they usually find that they then need a bench polisher or a bench grinder, then maybe a tumbler, then a lapidary machine, maybe a lathe, a wet saw, and so on. And after all is said and done, they could have ended up spending over $3,000 on all these machines. And aside from many of them being used only occasionally, space is also a serious concern. Most hobbyists, especially those living in an apartment, just don't have the space for that many machines. This tiny machine that's capable of doing so much, I call it the gumball, by the way, fits neatly on your desk or workspace and can be built for around $65, give or take. This costs less than any of the single dedicated machines I mentioned and would be able to do the work of all of them and a lot more. Alright, so that's my pitch. Since I'm currently out of work and I have a lot of spare time but little money, I've decided to ask for a minimum donation of $10. For this, you get all the 3D files to make your own base machine. I'll film a build tutorial. I'll create a parts and suppliers list. You'll have access to all the accessories available now and those that I'll make in the future. And I plan on making a ton of add-ons. And I'll even provide some support if you're having trouble building it. But trust me, it's very easy. I designed the case to be dummy-proof since I modeled all the part placement into the case itself. So it's obvious where everything goes. Assembly would be a breeze. I understand that there's some people out there that maybe don't have a 3D printer or don't know anyone with one, but you've always wanted to get into 3D printing, but maybe you found it intimidating. All I can say is there has never been a better time. When I first got into 3D printing, the cheapest machines cost several $1,000s, but now you can get a very reliable machine for like $150. And with inflation the way it's going, that probably won't be for long. And if you do get one, this build would be a perfect first project to learn, since you'd be following very detailed instructions and you'll have available support, a community, and the finished machine would have easily provided the value to justify the cost of even buying a printer. I've already reached out to a vendor on AliExpress, and if enough people show interest, they seem willing to maybe offer all the necessary parts in one box. That would make it easier and maybe come with an additional discount as well, making the machine even cheaper. And if enough people are interested in buying a printer, I can reach out to a manufacturer and also see about getting a discount code for that as well. Alright guys, so that's my machine and my idea. Hopefully enough of you guys are interested to get this project going. I'm not sure where it ends, but if it was up to me, I would love to see this project get enough support to progress to some pretty advanced conversions, like maybe a stone faceting machine or a diamond ring saw, even a parts kit to convert it to a rose engine lathe. That would be awesome. And since this would be a sort of open sourced idea, maybe others create attachments and find uses that I never thought of. 3D printing definitely makes this possible. The only thing missing is your support. Alright guys, thanks for watching, and I will see you in the next video.